I don't know about you, but every once in a while I can end up in a meeting with our network securities personnel and they start talking in their technical mumbo jumbo and I really don't know what's going on. So terms like firewalls and pinholes and tunnels and proxies, and don't forget reverse proxies, registrars, ALGs, whitelist, blacklist, URLs, URIs, UAs, finally back-to-back UAs. What does it all mean and what does it mean to me? Well, stick around as we address this in today's session on firewalls, SIP servers, and SBCs. What's the difference? Thanks for listening. All right, so let's start with why do you care? It's important to understand the threats that IP communication systems face, and generally they really fall into these three categories. The first being extortion, and this is where fraudsters threaten to disrupt or disable your service or enterprise unless you pay them some kind of ransom. They'll threaten to bring your services to a knees through a denial of service attacks, flooding your servers with SIP registrations, malformed SIP headers, or flood your service with short calls, tying up revenue-generating sessions. And this happens both on the enterprise side and also to service providers, tying up sessions. The second threat is intrusion, trying to break into your call server or endpoints or other network elements in hopes of collecting some valuable information. Starting with a network scan, a fraudster can inventory the equipment on your network, then use brute force attacks to hack into the servers or devices. Intrusions often combined with phishing attacks that collect passwords and other credentials that help them perpetrate their crime. Well, the third and the end goal for many of the fraudsters is a theft of services attack. And this is where they're going to use your SIP trunks to make international phone calls, often to premium rate telephone numbers that are overseas, and of course sticking the end customer enterprise with the bill. Not a very nice thing to do to people. And this is all very real. The New York Times published a story a couple years ago about an architecture firm that suffered a theft of services attack, and it ended up with a bill from the carrier for $166,000 in toll calls, and that all occurred in one weekend. And obviously a devastating loss for a small business. And if you're working for a carrier, you'd say, well, what do I care about it? But it really, wouldn't it be nice or make sense to protect your customers from these kinds of attacks? Well, or possibly even offering protection as a premium service? Well, those are some of the ideas we're going to talk about a little bit today, but time for some introductions. I'm Alan Percy. I'm the Senior Director of Product Marketing at TelcoBridges. And we're also joined today for part of today's session by Luke Morissette. He's the Director of Customer Support and one of the founders of TelcoBridges. And Luke, it looks like you're connected.
Yes, hello, thanks. Glad to be here, Alan.
All right, great. And behind the scenes, we're joined by Harry Wakefield. He's our marketing communication specialist who helps out with managing the Q&A during today's session. So thank you, Harry, for your help. So a quick look at what we got planned for today. In today's session is we're going to start out with a description of what are firewall SIP servers and SBCs and get into a little bit of how they work underneath the covers. And that helps with the understanding. We'll talk about why you need them, what role do they play, and how would you use them? What do they do? And then sometimes more importantly, what do they not do? Each one of these has distinct capabilities, and we'll contrast and compare them. And then lastly, we'll finish up with where you can learn more. And our hope is to finish all this in roughly 30 some odd minutes. So we'll try to keep it quick and concise today. So before we get any further, as you know, any craftsman or a handyman knows, having the right tool for the job significantly improves your chances of success and also on staying on budget. And the same is true with communications network design. You know, knowing what tools are available, what they do, and more importantly, what I said before, they don't do, is really, really important. And so this is sort of the theme for today's session, is really understanding the tools that you have here at your fingertips to make sure that you use the right tool for the right job, and that's our goal for today. So we wanted to start with just we call it a little SIP, right? I hope most everyone who's on this call has been exposed to some extent to SIP, or Session Initiation Protocol, which is defined by RFC 3261. And by the way, if any of you haven't had an opportunity to download it and just peruse through it, it's great late night reading for those nights when you can't fall asleep. But it's critically important, and it defines a lot of the specifications for modern communications. But it's got a couple of issues, and one of them is the specification is pretty loose, with interoperability issues as a result. And what do we mean by loose is there's a lot of mays and shoulds and those kinds of soft words in the specification. So that gave a lot of latitude to developers who built systems out of it. And this interoperability issues still to this day causes some problems in deploying communication networks that need to be resolved. Another element is separating the call control and signaling from the media. And while this architecturally has some huge benefits, it causes some challenges with security, and we'll be talking about that as we go through. Next is we kind of kid it and call it a chatty Cathy. There's a lot going on with SIP. As a matter of fact, that diagram on the right is a basic voice-only call. You see the invites going back and forth, the 100 trines, the 180 ringings, 200 is okay, the ACKs. What you don't see is all the SDP going back and forth, and of course any registrations or subscriptions or notifications, any of that. There's a lot going on with this protocol, and keeping track of it all can be a challenge. While we love SIP, it's got a couple of bumps in the road that make it especially difficult to secure and to challenge. And I don't know, Luke, do you have any thoughts, any additions you want to add?
Not on SIP. I think SIP is being used all over the place, and it's being. I think the interoperability issues are being less and less important because there's more and more exchange of information through SIP, and we have experience on that, of course, and I think it works pretty well everywhere we go.
Right. Well, the security issues I think are becoming bigger and bigger. So before we move on, this is an area that we wanted to make sure we talked about, because if you get anything out of today's discussion, understanding which of these devices and elements work in what parts of the protocol. And if you've taken or gotten anywhere near a networking or communications class or seminar, you've heard about the OSI model. And what this does is it carved up the various elements to build a protocol into 7 different layers, from the physical layer, meaning the connection to a wire or a wireless connection, all the way to the top to the application layer, which is how the information appears within an application. How does the application use the communications? And there's all these layers in between, and I won't get into what they all mean, and there's plenty of content on the Wikipedia that explains it all. But these elements we're going to talk about today work at different layers within this OSI stack. And maybe, Luke, I'm going to ask you real quick, maybe just explain the 4, we got network switches, firewall routers, SIP servers, and session border controllers, and how they impact or how they interact with the different layers.
Right, Alan. The network switches manage like the low-level transfer of information, right? So here we see the Ethernet, but it's also MPLS networks, VLANs, optical networks. So it's all managed by the network switches, but it doesn't do anything else at the upper layers, right? If you go a bit higher into the routers, then you manage the IP traffic, also ICMP traffic, the ARPs, and it can manage transfer of information between different networks. If you go just a bit higher, you have these firewalls that are usually built with the routers, and they can protect against different type of traffics coming into the network. So you can limit the unwanted traffic, and also maybe different types of attacks. However, as you can see here, it doesn't really go to a higher layer like SIP. You need to have other stuff for doing that, right? So if you look here at then the SIP servers, they run the SIP session. It's only for management of SIP calls. It doesn't really manage the media path. It only negotiates the media path. And then you can do maybe some call routing, but it's really based at the SIP level. So to be able to merge the SIP, the firewall, and all these functionalities, you need to go with a session border controller, and then you can manage both the SIP, the firewall, and also the media traffic, and protect yourself against all these types of information that comes into your network.
Right. Yep. And this again is, you know, if there's one piece we just wanted to leave you with more than anything else, is the how these various pieces interact with the various layers, and the I'll call it the span of responsibility is very different between these. So, all right, so let's dig in and talk about in more detail some of the functions of these elements here. So starting out with a firewall, I think most everyone, you know, you're exposed to firewalls in your home network, you're exposed to obviously a lot of conversations, and I think most everyone knows that Firewall's real main job is to pass the good information and, of course, block the bad stuff. In general, how firewalls work is when a session is set up by some kind of server that's in the inside of the network, it opens a set of ports. Usually, it's web traffic, right? Or it might be email traffic. It open those ports up, and it's looking for some kind of response from the network, the untrusted network, and letting those responses go back through. So it's kind of, you know, opening the gate, letting the traffic go out, and then letting any kind of response come back through that open gate. But it really doesn't know what that traffic is. It doesn't. In general, firewalls are ignorant to the traffic. It's again partly because of the span. We talked about a couple of slides earlier about the the layers that they work in. And obviously, if any traffic shows up that's not a response, default configuration of firewall would just reject it, drop it, and ignore it. So, any notes on this then, Luke?
Well, the only thing here is you have your private network and your WAN interface, which are totally separate, right? They're not connected except through the firewall.
Right, right. Yeah, good point that out. So, and summarizing that from a responsibility and capability, we just chatted about the packet filtering is usually done at layers 2 to 4, and that partially is done by the router and partially done by the firewall. Tracking and passing the good traffic and blocking this unsolicited traffic. There's also pinhole management, and this is opening and closing that gate, as we talked about. There's also a capability called packet forwarding. We'll talk about when we get to the deployment models. We'll show in a moment with packet forwarding how that fits. And then in some cases, other functions like network address translation, which is, on the previous slide, we kind of skipped over it real quick. Let me go back to it. You notice the IP addresses on the devices on the right are articulated, are local IP addresses. And of course, on a WAN side, on the internet side, are the public IP addresses, and compressing or hiding all those IP addresses on the right is one of its responsibilities. And in many cases, they also combine it with DHCP, which could also be done by a separate server. In a large enterprise, it probably would be, obviously in a small SMB network or in a consumer network, it might be combined in with a router firewall. So I think most everyone gets what firewalls do, so we'll move on. All right, so SIP servers. SIP servers are an element that is part of the SIP specification. It has SIP registrars, there's SIP proxies, and a few other elements that are defined by the SIP specification in RFC 3261. In a nutshell, in general, what a SIP server does is when SIP messages arrive, there is some engine. In a lot of cases, it's a script engine or a scripting language that then can process the header. It might do some manipulation on it. It might choose to keep a message. It might reject a message based on its form. It might fix up the header. It might add information or delete information or do database dips to add this information, and then pass that information along to a routing engine, which then would deliver the SIP message to the appropriate destination. So in a lot of cases, how it's used is there might be multiple SIP applications, let's say to scale a large application, let's say a large conferencing application. So you might have 3 servers on the right, and your request to join a conference would come in through a SIP message. The header manipulation would then make a decision, do whatever fix-up it needs to do, and the routing engine would forward that request off to an individual server for processing. And this is very similar to the load balancers work, or large load balancers or application delivery controllers are done in web services. One important note, though, is you'll notice that the media down at the bottom just goes around the SIP server. SIP servers don't touch the media. In general, this is outside their responsibility. And you'll also notice too that the public WAN, the 34.001, is the entry point for the SIP server, and these applications have to also have public IP addresses because the media has to make it to the application. So the media ports on these SIP applications often is exposed, again, because the SIP server doesn't touch the IP addresses. So anything I missed there, Luke, on the description?
Yeah, well, there's just one thing I want to say here about the media. Here we see the media is passing separate. There's some SIP servers that can attach some other application to pass the RTP traffic. And when you do that, then the RTP traffic passes through the server that you run, also the SIP server. So you need to be careful, because this will take some of the resources of the device to pass all those packets from one side to the other.
Right. Yep, good point. So just a quick summary of SIP servers. There's a couple of real popular ones, Cama-Alio, if I pronounce it correctly, and OpenSIPs are very popular ones. They're usually used along with Asterisk platforms, but there's lots of other use cases for it, and they're excellent SIP proxy routers. They do a great job with SIP header manipulation, do an awesome job with routing and load balancing. They're very efficient, lightweight. They are a little bit complex though, because they're script-based configuration, and there's a lot of expertise required to figure them out. There's quite a bit of I don't know, learning curve, I guess, that's involved with it. But there's a couple things that they don't have. They don't have a back-to-back user agent, which we'll talk about in a moment. And that side effect of the potentially could expose some network topology if you're not careful. And of course, there's no media handling, so they don't do anything to help you with some of the other media processing functions. So that's a quick summary of SIP servers. So let's move on and talk about session border controllers. In last month's session, we introduced them in a little bit more detail, but just a quick summary is, a session border controller is, a network function that sits in the edge between two different SIP networks. And this particular example here might be the wide area network on the left and the local area network on the right. And it would generally sit at, one of the two or both of the networks would have a session border controller providing this network function of mostly protection for that particular network. So it's kind of the gate in and out of those networks, but it also might be used to perform some interoperability, resolve some interoperability issues. Might be used to measure traffic. It might be used to measure voice quality. There's a whole host of things that SBCs are capable of doing. And again, if you missed last month's SBC webinar, specifically on it, highly recommend. You can find that in our video library on either on our website or on YouTube. So just any quick comments, Luke, on that?
I'm all good with this.
Okay, all right. So let's get into the nitty-gritty of session border controller. This, Luke, you can jump in on some of this here too. So what we did is we just took a very simplistic internal view of what happens inside a session border controller. And there's a couple of key elements here. One of them, and one of the most important ones, is this back-to-back user agent, or the B2B UA. So you can check that buzzword off your list, which consists of two things: a user agent server side and a user agent client side. And essentially what's happening is a SIP session comes into a session border controller, and what it does, it terminates the session. It actually responds to the SIP messages and terminates it, and then converts the session into a series of states, which then the back-to-back user agent can then make intelligent security decisions about. and then if it so decides to pass the call on, it will now instantiate or initiate a new session using a user agent client to instigate a new session, and then all the state transitions between the two sides are always passed through the back-to-back user agent. Side effect of this is that any security threat or any interoperability issues can be resolved here within the back-to-back user agent at the point at which when the call is terminated. So you can kind of think of this as, instead of opening the gate, you come to the front gate, you hand somebody a note, they read the note, and then pass the note into whoever's inside the house. They don't actually let the individual through the gate. It's a security methodology. And then after that, then there's a routing engine, and that routing engine often is either script or GUI based to redirect the call off the various applications or destinations on the backside of the session border controller. And one of the key things is that the media also passes through the session border controller. It's optional, but a lot of networks choose to have the media pass through the session border controller, stopping at a media engine on the way for any conversion or voice quality measurement or encryption or all kinds of other functions that might be necessary to fix up the media before you pass it along. So Luke, you got anything you would like to add to this?
Yeah, a few things. First, there are special rules, right? Because when you separate the two networks, sometimes, like for registration, for subscribe notify messages, you need to modify what you receive, but there's some of the information that still needs to be passed to the internal network and going back out. Because in a regular call, for example, it's really separated. These are two SIP calls, one internal, one external, right? So with registration, we have some manipulation to do to make sure that the right information is conveyed to the internal registrars or other SIP applications. Okay. The other thing is here we don't show the firewall. I don't know if you want to talk about this now or.
Yeah, go ahead. Why don't you mention it
Just
now?
a little bit, Okay, so on the left side, on the public WAN, we have in SBCs usually there is a protection there, right? So anything that comes in SIP or media will pass through this SBC firewall, and then it will be managed, right? The SIP sessions will open media paths, and they will all be managed to open the right path at the right moment and close the path when the call is finished. There is also a firewall on the right side going to the internal network, right? Because there could still be some things that happen on an internal network to try to block the system or overflow the system, and there is a firewall also on the right side. So that could be interesting in some types of applications.
Good. Well, thanks for adding that. All right, so what we want to do then is talk about some of the deployment models that we see typically in many networks. And this diagram here shows a deployment model where an SBC is used behind an existing firewall. So this might be an enterprise deployment, it might be moderate-sized service provider, but it's somebody who's already got an investment in a firewall or they would like to pass their traffic through the firewall and then connect not only to their LAN but also to potentially to their call servers. And Luke, why don't you explain what this tunnel is and what this is all about?
Yeah, so what we have to do in the firewall, because the firewall doesn't know about SIP, we need to open specific ports for it to pass the information to the SBC. Now, what you do in the firewall is just relay those ports, those IPs. You can restrict as much as you can. However, you will need to open additional ports for the media, right? The RTP traffic that goes through that tunnel, and the firewall won't really be able to protect, manage those ports, right? So everything will be passed to the SBC, and the SBC will still have to do the firewall job of protecting against the traffic that is open through the tunnel there.
Right. Yep. So this is again, it's fairly common. This is obviously pretty common also to an enterprise applications where you're going to see an SBC sitting in front of a call server, again behind the WAN, and a lot of the materials. If you do some poking around on the web, a lot of the vendors when they talk about deploying their call server software with an SBC, that's one of the first things that's in their instructions, which is you basically have to go to your firewall and set up this tunnel, which is using port forwarding on the firewall to pass it. So the next configuration is when you put the SBC beside the firewall. And so Luke, you want to walk through this?
Yeah, so this one is similar, except you will need another IP to be able to receive this traffic. On the left side here, we show the untrusted network. It's the internet, but it could be also a private or semi-private network even there. So then you receive the traffic destined to regular application through the firewall, and only the ones that are destined for SIP traffic through the SBC. This then relays to an internal network. Here we show that it is the same internal network, same subnet. However, it could be separated as you need it into your network.
Right, right. And the idea is that that your SIP traffic would go to the secondary IP address. The internal firewall and SBC would handle any potential attack,
Right.
and then the finished session that comes out of the back-to-back user agents dropped onto the LAN and delivered to the call servers.
Yeah. So this way you don't need to open ports in the firewall for traffic that you don't really control
right,
at the firewall level.
right. And this might be more typical. It's obviously service providers, but you also might see it in like large enterprise where the configuration of their firewall is highly sensitive, banks and big financial service organizations, et cetera. Obviously hyper careful with their firewalls to ensure there's no intrusion. And by having the SBC traffic separate gives them some flexibility that otherwise would be difficult to do on a standalone firewall. So those are two very common deployment models for SBCs and showing how firewalls and SBCs work together. It should be noted that in some cases people are using SIP servers instead of SBCs in this kind of configuration. And as we talked about earlier, that would give them some flexibility on routing and manipulation of the SIP messages and potential deflection of invalid traffic. So, all right. So we wanted to just cover one quick use case, and we've got lots of them in some of the other presentations, and maybe we'll do that next month, is just talk about use cases. But this is a classic enterprise deployment that we see over and over again. We went to Astracon earlier this year and heard from all kinds of people that are deploying Asterisk behind a session border controller or behind a SIP server. And they're kind of asking, what kind of role does the SBC take in these kinds of applications? And this could either be on-prem in a premise-based deployment, or it could be a cloud-based deployment. But the typical use case would be put a session border controller in front of the Astra server, providing connectivity for the remote or work at home agents or whatever it might be. And this provides this denial service and topology hiding to the network, but also too it passes along these registrations and subscriptions that come from these remote devices. The IP phones all want to register and they want to be able to have busy lamps and other display information. That all needs to be passed through. And lastly, NAT traversal, because if these people are working from home, most likely these devices are going to be behind a NAT, and the SBC can then work through the translations that are necessary in the SIP messages to get those SIP messages through the remote work-at-home users' network address translation in their home router or wireless device. So let's just go over a quick comparison between them. So we talked earlier at the OSI level how they operate, but we did is we came up with I think that's about 8 or 9 different functions and which one of these devices handles this. So certainly layer 2 to 4, and through the preventing DOS and DDoS attacks, firewalls can handle this, and all the other devices, SIP servers and SBC2. When it comes to SIP header manipulation and interoperability, SIP servers and SBCs can do this. Certainly routing, they both can handle it. Can do some toll fraud protection by protecting, looking at, creating blacklists, for example, protecting against dialing to, international numbers and these kinds of things. But when it gets to topology hiding for media, for example, and moving on to blocking robocallers, QoS management, transcoding and transcription, and media DDoS attacks, a session border controller is required for all these things. So this is really, a quick summary of the differences between them. Now, could you put together a SIP server with some other just RTP manipulation management software? Yes, you could. Can you combine a firewall with these things? Absolutely. These are all, again, they're tools that are in the drawer, and it's important to know, what their capabilities are to be able to deliver the needed functions for the network. So, Luke, any additions to this or thoughts?
No, it's complete here. Yeah.
Okay. All right, so we wanted to start to wrap up with just a thought about, we at TelcoBridges now have been offering free SBC. It's a full feature session border controller software package designed for either bare metal or virtualized implementations. We have additions for VMware, for KVM, for bare metal, and also too for AWS. At this point, so there's a lot of flexible different deployment models, and it includes many of the the features and functions. Somewhat we've talked about today, but there's many other things way beyond that. And again, we've covered some of these in some of the previous webinars. And of course, you can learn more at freesbc.com. So we wanted to wrap up with just kind of share now a little bit of what's going on. As I say, enough to be dangerous in the workshop. But we want to encourage you to continue your knowledge. This is critically important. Just enough to get started. There's lots of resources available to help you with growing your knowledge. This starts with some of the materials we have on our freesbc.com website, including downloading a free copy of the software that you can use for your own education. And one of the critical things is our frequently asked questions at forums.freesbc.com. That we've been accumulating questions and answers over the last year now, and gotten some great questions accumulated on that page. And that's a quick way to learn a lot about its use cases and feature specifics and just general SBC questions. And last but not least, of course, is our video library at freesbc.com/video library, or if you go to YouTube and search for TelcoBridges, you'll find the videos from some of the past webinars and past sessions. And this is a great way to get going with that. So now it's time to move on to Q&A. So just as a quick reminder, if you want to post a question, move your mouse to the upper left-hand corner of your screen, and a little Q&A panel will pop up, and you can put your question in the Q&A panel. So, all right, so we'll give everyone just a moment here to put your question. If you'd like to submit a question, feel free to do so.
Well, Alan, I can just do maybe just a small comment. We saw the OSI layers and the different functions and SIP server and firewall, and a lot of those things that are being deployed are mixing up those functions, right? So you have network switches with routers and routers with firewalls and SIP servers with or without protection, right? So and that makes a big difference when we go. When we try to explain all of this, right, we're separating the functions, but sometimes they are the same functions, right?
Right. Yeah, it's a good point, right? So some of these network functions often get combined into appliances, right? And then the idea is that the appliance gets deployed, provides multiple services all at the same time. It's a little confusing maybe for the consumer or for the user of these, but these are actually separate network functions that work maybe at different layers of the OSI model, and makes it convenient to deploy and install, providing multiple features. But it's important to understand what are those underlying features. So, all right, looks like we got some questions that have trickled in here. So Harry, you want to hit us with them?
Okay, so we got a question from Gordon, who asks for hosted telephony services. I'm sorry, servers. Are the NXXs stored Oops, I just lost the question.
Yeah, stored in the SIP
Stored
server.
in SIP server or the SBC.
Yeah, okay. So the NXS, so telephony server, the NXS stored for hosted telephony. So this would
Yeah.
be, go ahead, Luke.
Yeah,
You got
so yeah, I do have an answer for that. Let's say the SBC from TelcoBridges does not keep those numbers stored in the SBC. We can attach to a SIP registrar, and then you can store some of those known subscribers there. Or there's a way also from an SBC to access an external resource to be able to reach those numbers. So we can verify if those numbers are valid. We can modify those numbers if you need change the local number portability and stuff like that. So but the SBC doesn't store them locally.
Yep, good. Okay. All right, Harry, on to the next one. There's a good one here about DDoS.
I can ask the question, how does the SBC protect against media DDoS? So the reason the SBC can protect against media denial of service attack is because we can manage this media, right? So we receive all the media traffic, and it is being sent to the destination, but also processed for any scenarios which we would describe as a denial of service attack, right? So we can verify that there's too much traffic coming into those opened UDP ports, and then we can say this is not RTP traffic, and there's various criteria that we can use there. But the important thing is that it is possible to capture all this media traffic at line rate and analyze all of it to make sure that it is a valid traffic only that gets through the system.
Right, and probably one note to make is that one of the things session border controllers do is because they're part of the session initiation and they oversee the SDP going by, they know what is supposed to be valid media,
Yes,
right? So they know what the expected bandwidth is going to be for
exactly.
a
How much packets are you supposed to receive, and what type of packets, and we can analyze very deep into the RTP packets to make sure it is a valid one.
Right, right. And then if media arrives at a particular UDP port that far exceeds that data, or packets are too large, or like I said, the bandwidth's too high, then the SBC can say something's wrong here, this is not right, and can cut it off. Okay. Maybe I'll ask the next question here. So, question about the SBC and IMS. Is considered SBC only or SBC plus SIP? So probably the best thing to do is just talk about the role of SBC and IMS. Luke, probably how about that?
Well, yeah, well, it's SBC and IMS is managing the SIP traffic, right? So it's really it's really included, right? SBC, it's not SBC plus SIP, it's really SBC, which includes all the management of the SIP traffic. In IMS, we add the media traffic on this device, right? So,
right.
But it goes very well into the IMS network.
Sure. Okay. Here's a specific question about FreeSBC, which is from Jamil: is how many calls per second does FreeSBC handle?
Well, it depends on what type of platform you install the FreeSBC on. The highest call rate that we can get is on a bare metal server, and I think the latest number was 1,400 calls per second, if I'm not mistaken. It's there. If you use other type of platforms like virtualized VMware, maybe you can get 700 or even more, depending on the server you're running VMware on.
Right. Good. So let's see. Harish asked the question: how can the SBC be managed from WAN and still be secured over the WAN? So that's a great question of all the how are management ports and IP addresses used? That would be a great description.
Yeah. So exactly. The interface from the WAN can be protected as well, right? So it could be set up on a totally separate network, which could be a private network, or we just protect that from source IPs. We can also decide a very specific port to be handled there, and we can also protect with, of course, a password which is very secure. We could also limit there's other ways to limit it using SSH networks interface maybe. So so we can definitely make it secure even if the interface is over the WAN.
And one critical thing for a lot of folks is just the knowledge that the management interface can be on its own complete separate network. And I think that is typically in large, high security applications is how it's done. So Nitin asked a question about using FreeSBC as a PCSCF in an IMS deployment. So that's a mouthful.
Yeah, well, I've studied that before. I don't remember everything that the CSCF does. However, I think it can do part of the job and maybe not all of it. So we would have to check exactly what is required, because these IMS descriptions of elements are usually very theoretical. So we have to identify exactly what is needed, and then we could verify if the FreeSBC can do all of it or only part of it.
Right. Good. All right, looks like we got to the end of our questions. So, and we're just about out of time here. So I did want to just kind of wrap things up here with a couple of closing comments. As we noted in the opening housekeeping, as a registrant, you'll be receiving the TelcoBridges newsletter email within a couple of days. And in this email will be some links to recordings, not only the recording of today's event, but the slides and a link over to the FAQ. And so, please do share your content with others. Would find it helpful. And if you are viewing this recorded session, as a recorded session, and found it helpful, be sure to click on the like and subscribe buttons. And better yet, why don't you register for the next webinar and join us live, like those of us that are on the call here and got to ask some questions. It's a great way to learn more and be engaged. So, and with that, we'll want to say thanks for joining us today. And that's it from here. Wishing you all a good day and a great holiday season. Thanks again.